Now let's move on to arithmetic operators. So Java has all the basic mathematical operations like addition, subtraction, multiplication, division, and also the mod operation. If you don't know what that is, please check the previous lecture. All of these operations are binary operations, which means that you need two operands or two values that you want to apply the operation to. So for example, addition, you need two numbers to add to each other. The same with subtraction, multiplication, division, and mod. We have other type of operators called unary operator. We will look at some examples later in the lecture. Okay, when you have more than one operation in the same expression, like this one, 3 plus 10 times 2. Some of you might recognize that the multiplication has to be evaluated first. So the result of this will be 23 because we multiply 10 by 2 first and then add 3 to it. Some of you might have thought that the result would be 26 by adding 3 to 10 first, which gives you 13, and then you multiply it by 2. This is incorrect. We have what we call operator precedence rules, which means that some operations have to be done first. They have higher priority or higher precedence. In most programming languages, multiplication, division, and mod have the same precedence, which is higher than addition and subtraction. Okay? So when you have multiple operations, first you do the multiplication or division or mod, and then you do any addition or subtraction that you have. When the operators have the same level of precedence, so when you, let's say you only have multiplication and division, in that case, you evaluate them left to right because it makes no difference. One thing to keep in mind is that whenever you have parentheses, if you have an operation in parentheses, that will always have to be evaluated first. Okay, so you evaluate the number inside the parentheses and then you do everything else. It's like overriding those precedence rules. So in the previous example, if we wanted to add 3 and 10 first, we will have to write it this way. Okay, in Java sometimes we end up with different results depending on the data type of the operands in our expression. If all the operands are integers, this is called an integral expression. If all of them are integers or any integral data type. So here we have some examples where x, y, and z are all integer variables, and then we have these expressions where everything, all the numbers and variables are integral data types. The result of this integral expression will also be an integer. On the other hand, if we have an expression where all operands are floating point variables or data types, then that is called a floating point expression, and the result will also be a floating point number. And here are some examples. We also have some mixed expressions where you have both integral data types and floating point data types. For example, here we have 2 plus 3.5 and 6 over 4 plus 3.5. First, depending on the precedence of the operation, you will have to evaluate each part separately. So here 6 over 4 have to be evaluated first because division has higher precedence than the addition. But 6 and 4 are both integers, so when we evaluate the result, it will have to be also an integer. If you do this using a calculator, the result is 1.5. Okay, but when it is an integer, we discard that fraction 0.5 and the result will be 1. And then we add 3.5 to it and the result will be 4.9. Okay, so when we have both types, an integral and a floating point number, the result is also a floating point number. But when both types are integers, the result is an integer, which means we will discard any number after the decimal point. And you can try this in Java. So if we have 6 divided by 4, this is an integral expression. The result gave us 1. But if we used a floating point number like 6.0, right? So this is a floating point number and this is an integer, so we have a mixed expression here. the result will be 1.5. Now if we want to add 3.9 to this, we will have two parts that are floating point numbers, and the result will also be a floating point number, which is 5.4. But if in this part we only had integers, so 6 divided by 4, and this will be evaluated first, so the result will be an integer. It will be 1, so the result will be different. So you have to keep that in mind whenever you're evaluating expressions in Java. If you want your numbers to be accurate, you will have to make sure that at least one of the operands is a floating point number, like this. We have something in Java called typecasting, which is a way to convert between different data types. You might want to convert a floating point number into an integer. You want it to be a whole number. But again, keep in mind that when you convert a floating point to an integer, you just get rid of the decimal points. So it's not the classic way of rounding to the nearest number. It's more like taking the floor of that number. So let's say you have the number 6.5 and you want to convert that to an integer. The way to do that is between parentheses to specify the type that you want to convert to. So in this case, I'm saying convert this number into an integer. And now if I run this, the result is 6. So it doesn't matter how large this decimal value is, the result will be the floor of that number. So what do you think would be the result of this? In this example here, this typecasting is applied only to this number. So first, this will be converted to the value 6 as we have here, and then we add 1.5 to it. So the result will be 7.5. If we wanted the conversion to be applied to the result, we will have to surround this with parentheses. So the precedence rules apply here. If we have parentheses, then that expression will be evaluated first, which gives us 8.4, and then that number will be converted to an int. So the result will be 8. You can use typecasting to convert between all primitive data types. That means you can also convert characters to numbers. So let's say I have the character capital A and I convert it to an integer. The result will be just the number, the numeric value, the encoding of the character A. And you can do that with any character. For example, character 1, as we saw earlier, the value should be 49, right? We could also do the opposite. We could take the number 49 and convert it to a character. And the output is 1 because 49 is the encoding for the character 1. 65 is the encoding for the character A. So here we have the encoding for the character A, which is 65, and we add 1 to it, it becomes 66. The encoding of the characters depends on their alphabetical order. So the encoding for B is just 1 larger than the encoding for A, so the result becomes B. So try doing this exercise. I would like you to use typecasting the way I just did to find the Unicode value, the numeric encoding of each of these characters.